Hello, I'm Armando Vella, and today we're going to be talking about uncovering insights from employee data. So the task of the team was to gather insights on attrition. What are those three main factors that lead to attrition? The other thing that we had to do was build a model to predict attrition, and there was a threshold set in place to make sure that we had 60% sensitivity and 60% specificity. Lastly, we needed to build another model to predict monthly income and make sure that the RMSE, which is the root mean square error, is less than 3K. So just a review of the data set. There were 870 observations or employee records, and within this data set, there was also 36 factors. We did make three modifications to help with the analysis. First, we modified attrition, since it was yes or no, to 1 or 0. Then we did that to gender, since it was also female or male, as well as modified overtime, since it was either yes or no. So what are the factors leading to attrition? Well, within our analysis, we initially ran histograms for all numeric variables. After, so that we can gather the chi-square p-values, we did a logistic regression model for each variable with respect to attrition. What we did find out was that there was 14 variables that were identified as being statistically significant, p-values less than 0.05. And as you can see within the table below, the top three were actually overtime number, job involvement, and total working years. So factor number one, overtime. It had a chi-square p-value of less than 0.00001. So the attrition percentage for employees working overtime is about 36%. And that's 80 divided by the 252 total observations within the column 1, which is on the far right. In comparison, within the far left, within column 0, or no overtime, there was only 10%. So there was actually a threefold increase for those with overtime with respect to not having overtime. So factor number two, job involvement. So as you can see within this chart, job involvement number one actually has the worst attrition rate at 47%. In comparison though, job involvement number four has the best attrition rate at 9%. Finally, the third factor, total working years. So with this normal distribution, you can see that the higher attrition rates are within 0 to 10 years. And then there's a bit of a drop off until you get to the 30th and 40th year. So on to our next goal, and that was the attrition prediction model. So the first thing we did was normalize all numerical data to help with our predictions. Then, for the data set, we divided into a training and a test set. 70% was for the training and 30% was for the test. Our K-NAN model was used for attrition prediction, and we used it at k equals 5. These are the results. So our accuracy was 83% prediction rate. Our sensitivity was 84%, which is greater than the requested 60%, and our specificity was 71%, which is also greater than the 60%. We've also included a confusion matrix if you wanted to see actual versus predicted. So for a monthly income prediction model, we use the linear regression model. First, to help pare down our variables, we ran a Pearson correlation test and we identified two variables with greater than 50% correlation. Next, after that, we did a stepwise selection for the two numerical variables identified and it included all categorical variables. As you can see within the final linear model, there was actually only 4 variables that we used: job role, job level, an interaction of job role times job level, and then total working years. For our summary statistics, we have an adjusted R-square of 95.3% and an RMSE of 985. So in conclusion, there are 3 main factors leading to attrition, and that is overtime, job involvement, and total working years. Our prediction model is greater than the requested threshold, as well as our monthly income prediction model is calculating less than the requested threshold of 3K. Thank you for your time. Do you have any questions?